The relationship between surface cover and tons per hectare residue, essentially, this is the curve that is very common, but at 3 to 4 tons per hectare, this is a common threshold where we start to see problems with machines, with seeders, particularly tine seeders. But this is also the start of the threshold that we're trying to achieve in terms of quality of no-till. On the machinery side, what's particularly, I think, important to understand is the relationship between tons per hectare as well as function of the crop yield and the harvest index. And in Australia we have harvest index values of say 0.3 to 0.45, and that gives us a range of expectable residue loads that we can get in paddock. But the process of harvesting concentrates residues behind the harvester and often doesn't really spread it that uniformly. So in a paddock we might have quite non-uniform residue loading, and we do have potentially this is the values we can attend to 14 tons per hectare versus 2 to 4 for just a crop of 4 tons per hectare. So that's the range of variability you can get just from the biasing of harvesting. So these are things to think about when talking about the needs to improve the capacity of seeders. So the main thing with the tine seeders, that's the first part of the talk for me today. Tine seeders, the key or the key word here is stubble length, and that's really what drives the capacity of tine seeders. So anything to reduce stubble length is relevant. Cutting short at harvest, chopping and spreading residue evenly. We'll look at ways to increase the capacity of seeders as well, but essentially it's the balance between what the seeder can do and what you have in the paddock. In terms of operations in the field, operating in dry situation and at lower speed helps. So if you have a challenging paddock, often that's part of the strategy. More recently with guidance, inter-row sowing is a big part of the solution as well. But not always easy to achieve everywhere, and that's subject to how well the seeder tracks behind the tractor. So in terms of tine seeder capacity, this is both about avoiding blockage of the machine but also minimizing clumping. And we did a bit of work looking at the impacts of clumps. This is a typical sort of result with a heavy crop sown by a tine seeder with lots of clumps. Essentially, the clumps are concentrating the side effects of residue. So there are many different physical aspects in terms of, we talked about nitrogen tie-up, but phytotoxicity, harboring of pests and disease. These are key issues that you get in clumps. But more so for us is about the establishment of the crop and how uniform that crop establishment is, especially crops like canola, which are quite sensitive. Harvestability, and also essentially the bigger the clumps, the more unstable the machine is, so essentially the higher the risk of blocking the machine. So we want to minimize that to avoid trouble in the paddock. So just a visual example of weed crops emergence and affected by clumps in the plus situation. In canola we can get much more patchy emergence, pretty much because of the physical interference of residue clumps over the seed row. And from that, essentially, in research, we can actually try and quantify this clumping impact. So what we do is we look at the length of the row that is covered by a significant clump, and we survey long distances. And then we're looking at the ratio, essentially a proportion of the seed row that is covered by a significant clump. So significant clump is different for different crops potentially, but we can do that post-emergence and get a fairly good appreciation of what that might be. And then we quantify this. So this is an example of a trial which we did quite a few years ago now, looking at the impact of types of tines from higher capacity to lower capacity. And typically narrow edge-on tines are lower capacity tines. They generate clumping much more quickly and easily. But this is just to show the range here, the situation where we had 3.5 to 4 tons per hectare stubble, a little bit more concentrated behind the header, and a high, like moderate 400 mil. And we went basically from a 1% to almost 4.8% clumping. So this is just the extent of the impact of machinery in that situation. So it's not a large amount. But when we look at how that impacts yield, I guess is that straight relationship essentially, depending on the season, but this is one of the few sets of data we have showing a relationship between clumping as, achieved in the paddock by the seeder and a direct loss of yield. And essentially, over the increase from 1 to 5% is an increase of 4% of clumping, and we have a drop in yield by 4%. This is, I guess, an assumption a bit. We haven't got too much data there, but in other trials we've quantified clumping, and we had much higher values. We've had instances where we could get up to 15, 18% of clumps. So essentially, potentially there a significant impact on the crop yield. And you can see the values of clumps here, or the clumping extent has increased a fair bit. The crop is a different crop now. It's higher tonnage, 5.5 tons per hectare, with much higher concentration in the header trail. A taller crop as well, 500 mil, but also wet residue. So these basically have a big impact on how the extent of clumping happening in the field. This is a visual impact of row spacing, essentially from a 10-inch row spacing to, 25 centimeter row spacing to all the way up to 68%, and obviously having a major impact on clumping there. So rotation crops established into thick residue. We also know that some crops do quite well at wider row spacing, but that's obviously part of the solution to handle residue. So from the work that was done in the mid to late 90s now, funded by GRDC, we looked at different styles and designs of tines and clearances, etc., and we came up with a preferred set of parameters for tine designs, and essentially a very large clearance, continuous profile, round, smooth edge. All of that is part of a superior tine design. And there are very few tines on the market that have actually adopted that. Only one brand, I think, in Canada did. But the closest that's happened, I guess, is to try and provide some add-on kits to existing designs to essentially get closer to that optimum design. But the key parameter for tine is what we call the vertical clearance, and this H value has to be as high as we can. But the work we did has managed to relate that value to stubble height, and we always try to have a vertical clearance at least 1.5 times the length of the residue to minimize the risk of clumping and blockage. So that's a bit of a rule of thumb to keep in mind. And some of the tines that are like the cold tine here are very restricted, essentially have limited hope really in residue retention systems. So tall tines will do better. And just talking about the add-on kits that are available to farmers. Essentially, these residue guards, we can see just to transform the existing designs to something that's closer to the improved design. And some polymer wrappings, all of that is just to try and make it a lot smoother and rounder edges. And also the use of residue cutting coulters. Now, the coulters can work if they cut through residue. That'll make a big difference. But if they don't, for example, if you operate in the soft soil and to wet residue and just essentially just hairpin or kink the residue, that actually creates bigger problems behind for the tine system. So the use of residue coulters is really warranted if you can actually manage to cut through residue. The second part of the tine sort of specification is the layout and how they're arranged, disposed across the different ranks on the machine. So, and there's a similar sort of dimension there, the intertine clearance in any direction, side to side, front to back, etc. And the smallest value on the layout is going to be the bottleneck of the machine. So we're trying to maximize that, and especially at the back of the machine where the clumps are likely to be bigger. So again, we do have some relationship, and typically 1.3 to 1.5 times the length of residue is a starting rule of thumb in moderate crops, but beyond, when the crop yields are higher, then we really want to have up to twice that length of residue as an intertine clearance. So essentially that means that row spacing especially has a big impact. So row spacing needs to be wider. You want to have much more deep machines, so 5 ranks or even 6 ranks now. And depending on how compact or expanded the seeding system is, then we need to have really large machines. And essentially that's the weakness of the tine seeder, is that you need to have a really large size machine and to provide capacity for residue handling. So in terms of I guess, managing stubble for that. Reducing length is the key, and we talked earlier about reducing the height of stubble, the double cutter bars, or doing some stubble reducing operation or cutting operations. There's different ways of doing that, but obviously it's extra cost, etc. And this is really, I guess, how inter-row sowing is making a much bigger difference in practice on farm, but it is all dependent on having sufficiently good tracking ability of the seeder behind the tractor. The tractor can be guided quite accurately, but this is also part of why farmers typically want to keep on wider row spacings, because you can inter-row sow a lot more practically and a lot more easily. Yeah, so essentially need for minimum row spacing and guidance there to achieve that. Okay, so take-home message for the tine seeders. Essentially maximizing clearance both vertically and within the layout is key part of the design stage. That's relevant to farmers if they want to sort of change row spacings. Typically that's a motivation to try and handle residue better. So you need to have a layout on the machine to actually achieve these requirements and not create bottlenecks on particular parts of the machine. There's a number of operations, but basically timing and decreasing the residue length. These are key operations to manage residue. To manage residue, essentially to improve the residue handling capacity. So the aim again from the research is really about minimizing clumping, not just avoiding blockage, because clumping costs yield according to research results. All right, second part of the talk is about disc seeders, the other type of tools essentially. Whereas for tine seeders, residue length is really critical. Essentially, the disc seeders, the situation is a bit different. One of the key incentives for adoption of disc seeders by farmers is the capability or the capacity to handle or to retain heavy crop residue. However, there are also quite strong limitations of these seeders in this environment, and one of them is hairpinning. Hairpinning is when the residue is pushed by the disc into the furrow and not cut, and that creates a whole lot of different problems, and that happens quite easily, subject to residue condition, but also subject to machine capabilities as well. So when the residue is matted, it's very hard to cut. You need a lot of weight, and essentially that's where residue hairpinning occurs. So the hairpinning essentially is about contact between seed and residue. It really affects seed germination and crop establishment, phytotoxicity effects, as well as poor contact between seed and soil. And in particular, with systems that use pre-emergence herbicides, the rate of crop damage can be quite significant. So there's also the fact that the furrow doesn't close properly, and then that creates a drying of the furrow pretty much much more rapid, which then really affects the germination as well. So essentially with these seeders, the ability to control hairpinning is central to making them work well. So examples here, on the right, control of a canola crop in burn stubble with a single disc seeder, and on the left, the same soil type, same sort of crop, but obviously with residue. And in this case, sowing at right angle to the harvesting, and we can see some zones of worse establishment and slightly better, which is in line with the harvested path of the essentially concentrated residue there. So this is very typical of an impact of residue with disc seeders on sensitive crops. But the strategy essentially is a two-pronged strategy. The first is to minimize the need for cutting residue, because it's such a difficult thing to achieve in practice, and then maximize the capacity to cut residue. So the first implication, I guess, of the first prong, which is minimizing the need for residue cutting, essentially this starts at harvest, maximizing the height of residue, so keeping the residue standing as much as possible, and spreading any of the loose residue as uniformly as possible, so that essentially disc will not have to encounter much residue to cut. Locating the disc in between stubble rows as well is part of the same strategy with inter-row sowing. And unfortunately with disc seeders, the tracking stability of a disc seeder is less than that of a tine seeder often. So it's more difficult to achieve that, especially at narrow row spacings. And the other option is to use residue managers. These are designed to push residue across to essentially get residue out of the way of the disc and control essentially what the disc sees while operating the furrow.
Why don't disc seeders track as accurately?
Well, disc seeders, a lot of the disc seeders have side forces. The single disc seeders have side forces. Yeah, a disc needs a lot of weight to do the job of penetration. So essentially there's very little weight left on the wheels of the seeder, which typically act as a rudder. So essentially it's a stabilizing force. So these are the reason why that happens. When you have you go through a hard patch, a compacted area versus not, so on the side of the machine, etc., you get a very different sort of set of forces. So all of that contributes to the machine sort of floating behind the tractor and moving side to side a fair bit. Yeah, but yeah, so that's part of the issue. But so the residue managers, essentially they're designed to remove the excess residue typically, and not to aim to get rid of 100%. The residue that has been in contact with soil is typically okay. It's been degraded sufficiently that it can be cut through a lot more easily. But yeah, so the different designs out there. This is a very standard design now that's being used in the industry. But yes, some farmers use them as well as soil throw to generate some soil throw to improve the or to reduce the crop safety or crop damage with pre-emergence herbicides. But it's a different use of the technology. Some of the early work we did with the early technologies of residue managers demonstrated some improvements in terms of improving canola establishment. So this is the data for different types of soils and residue conditions, where the control is a burnt residue, so that's our 100% reference. And then we can see that the impact of residue with a very conventional disc, the Barton disc, which is an older technology, but at the time was fairly typical. Essentially anywhere between 35 and 73% of the target achieved in burnt residue. That's the typical penalty that residue creates, and then we can lift that back up a little bit with the residue managers, so that's the extent of improvements we could get. Now this trial was done actually at right angle to stubble rows, but residues managers actually work a lot better when you operate alongside rows, but it's a lot harder to actually have a trial that's scientifically sound if you work alongside the same harvester and sowing directions. But so this is a conservative estimate of the performance. The other prong of the strategy to maximize the cutting residue cutting capacity essentially is to optimize the disc parameters and the stubble parameters to improve the effectiveness of the residue cutting process. So on the stubble side, essentially we know that wet stubble is very hard to cut and a lot easier to bend. So it's the wrong time to try and cut residue. Decomposed stubble is a lot easier. So obviously residue that has had a fair bit of rain over summer will be a lot easier to handle. We know also that cutting along the stem or at a slight angle to the stem direction is easier than at right angle. So that's got implications for how you drive, perhaps in relation to how the stubble has been laid over, especially in the wheel tracks of a header. And the matting of residue is a big issue that really is the main source of problems. Essentially, the thickness of residue mat is very hard to deal with for this seeder. So essentially, yeah, it's all in relation to what the seeder can do in terms of penetration capacity, so how much weight is available on the machine and how much of that weight can be applied to each unit. On the disc blade side, essentially, if we look at how residue is cut by blade, it's two sort of aspects there. One is what we call a wedging or parting effect from a sharp cutting edge, and the other one is a sliding cut. So it's akin to sliding a slice of bread, slicing a bread essentially with a knife. And so we need to have the two optimized to be able to achieve good cutting. That means that essentially if you have a soil that is sufficiently hard, not soft sand, then you can use a lot more of the sharp edge effect to cut through the residue. If you do, and that works quite okay because it's much harder to actually penetrate at deeper depths to try and achieve a better sliding cut component. But the sliding cut component is really what is needed to be optimized in sandy soils, because that's what essentially drives the cutting process. You don't have much backing of the saw to push against to try and just part the residue from just a sharp edge push. So the two actions really typically need to be optimized, and what this means is for a quarter, for example, there's an optimum depth. If you're too shallow, you're going to promote hairpinning, and you're probably relying mostly on parting and wedging. So it's going to be really sharp cutting edge and also a pretty hard saw to try and cut through residue in this situation. If you go too deep, which is often what you need to do to try and have enough resistance of the saw to cut through residue, essentially you also tend to push residue forward a lot more and accumulate and block the disc. So in between is where the optimum lies, and that optimum is different for different style and also different diameters of discs. So that's a quick wrap up of the of these issues. So the speed ratio is a key parameter that we've measured in our research, and the speed ratio essentially is the ratio of the peripheral speed, essentially rotation speed, as a function or as a proportion of the forward speed. So a ratio of 1 means that the peripheral edge of the disc blade is at the same speed as travel. But we can see that some of the measurements we made, essentially some configurations give us a slow rotation of the disc, which makes it difficult to cut because essentially the disc is trying to slow down the process of cutting. But different options here, like this is basically on the left a straight quarter, and then as we put a side angle to it, like a single disc seater, or we put a tilt as well, then we significantly influence what happens to the blade. And essentially this is the basis that explains that the single disc seaters typically are a little bit better at cutting residue, and when the vertical discs, but when they start to have a tilted disc, they lose their ability to cut residue. This is just to look at the impact of a blade design on speed ratio again. We can see that a new design of blade which can be used in two directions, for example, you could mount the disc blade in the wrong direction and tap to it, yeah, and sort of significantly impact the residue cutting ability. So a very different picture there in terms of speed ratio. Okay, take-home message. Disc seater residue handling capacity, essentially a two-prong approach, as I mentioned. Minimizing the need for residue cutting is the first thing, and then maximizing the residue cutting capacity on the machine is the other, and it's really geared to control the hairpinning issue with disc, and because controlling that is a driver of disc seater efficiency and efficacy. So residue managers and interior sawing is really an integral part of using disc seaters in the farming system where residue are retained. Just kind of mention quickly a new piece of work we're doing on the aquatill. I mean, probably a lot of you have heard of the aquatill from the work that Sandfire has been promoting. This is a new technology which is generating a lot of interest in industries like the cotton and sugarcane, but also in some of the grain cropping areas. And we're looking at now the efficiencies of using that technology and how we can use water rate and power requirement to try and essentially deal with the amount of residue we have. There are lots of potential advantages with using a liquid coulter rather than mechanical coulter, but that's sort of what we're working on, and hopefully coming with some recommendations there.